So far our life has been so smooth that we have completely forgotten there was something called friction. Now it is time to face the reality. There is no object which is absolutely smooth. Friction is everywhere. When one object tries to slide over a surface, there is a frictional force between these two surfaces, right? So that frictional force is what we are going to discuss today. Alright, yes. What is a frictional force? When you think of friction, so you always think of it as a negative term, right? No, a lot of things in the world happens because of friction. Simple act of walking, right? You can walk on a surface because of frictional force between you and the surface, right? So to realize this, you try to walk on an ice surface, right? Or you spill some oil on the floor and try to walk over it, right? Then that is very difficult because there is no friction. Friction is reduced. So friction is very important for a lot of functions in the world, right? So friction is very important force, right? Let us understand this friction by taking some example. This guy is trying to push this block in the horizontal direction. What are the forces acting on the block in the vertical direction? The weight force in the downward direction, against which we have the normal force in the upward direction. These two forces balance each other, so no vertical motion. But what are the forces acting on the block in the horizontal direction? The force applied by the person, so that is in this direction, but still the object is not moving, right? The object is supposed to move when a force is applied, but the object is not moving. That means there must be some force against this applied force, right, in the opposite direction. So the person is applying a force in this direction, so there must be some force in the opposite direction that prevents the block from sliding, right? What is that force? That force is what we call by the name frictional force, right? See, the two surfaces seem to be smooth surfaces, right? But they are not smooth, right? If you observe it very closely, right, there is some unevenness, right? So it is like zigzag, right? So this is unevenness. It is not a smooth surface like the horizontal, right? That means the normal force between the two surfaces is not always vertical, right? Because the two surfaces are like this, making some angle. They are in contact. That means the normal force is making some angle with the horizontal, right? Suppose this is the one normal making angle, say some theta 1, n1 making angle theta 1. That means it will have some horizontal component, right? If it is vertical, there is no horizontal component, but it is not vertical, it is making some angle. That means you can take the component. What is the component of this normal in the horizontal direction? N1 cos theta 1. That works against this force in the opposite direction, right? That force is acting in the horizontal direction. Similarly, there is another normal force, say N2 making angle theta 2. So N2 cos theta 2. So if you add all the horizontal components of these normal forces, then you will get the total force against this applied force in the horizontal direction. That means normal force is not always vertical like this, because this is not a smooth surface, right? So there are some normal forces which are inclined at some angle theta with the horizontal. So the components of all these normal forces in the horizontal direction is acting in the horizontal direction against this applied force, right? So this net sum of all the components of the horizontal, normal force, that is the frictional force, right? So just for understanding, right, so there is a frictional force because this surface is not smooth, so normal forces are inclined at some angle. You take the horizontal components, so they will form a force against this applied force. So this force is called the frictional force. Okay, yes. Now, so there are many cases, right? There are different types of frictional forces. Let us take one by one. Okay, take this example. This guy is trying to push this block and there is a friction force in the opposite direction. So who is that guy? So assume that that guy is the frictional force, right? Friction personified, right? So you assume that that is the frictional force because we can't see friction, so you assume that this is the frictional force, right? A personified frictional force. So it is acting in the opposite direction. So now this force applied by the person is balanced by that person. That means the friction acting in the opposite direction. So the object is in equilibrium. It is not moving. Okay. What if you increase the strength? Okay, increase the force. So that also we can't see visually. So assume that he grows bigger. That means the strength of him increased. That means he applies more force. Okay, he applies more force. Then what will happen to the friction? Friction will also increase in strength. So that means this force is again balanced by the frictional force. So again the object is in equilibrium, right? If you keep on increasing this force, the friction will also increase. So in any case, the object will not move because the force is balanced by the frictional force. You understand? So it is a variable force. Remember, friction is a variable force. This is one type of friction. What type of friction is it? It is called the static friction because the object is not sliding, right? Not moving. No relative motion between the object and the ground. So this object is not moving. So the friction that acts on the object is called static friction. So So static friction is when the object is not moving. Okay, so this static friction is not a constant force, it is a variable force that will keep on increasing as you increase the applied force. If you increase the force, the friction will also increase, so these two will always balance each other, so the object does not move. Okay, but there is a limit to this friction, right? So it has a maximum strength, so you keep on increasing this force, so friction will also increase, but the maximum limit of the friction is reached. This maximum limit of the friction is called by the name limiting friction. So that is the maximum value of the static friction, right? So after this, if you increase the force little further, then the object will start sliding, because this applied force overpowers the frictional force, right? Because the maximum limit of the friction is reached. That means this force is more now. So that means the object will start sliding, right? It will start moving in that direction. Okay. Now up to that point, when the object is not moving, that friction is called the static friction. What is static friction? When the object is not sliding, that static friction does not have any formula or anything to calculate. So this static friction is just opposite to the applied force. That's all. It is a variable force. It is opposite in direction, equal in magnitude to the applied force. That's all. But it has the maximum limit. That maximum limit, that is called the limiting friction, that is a constant value, right? The maximum limit is a constant value. There is a formula to calculate the limiting friction, right? Maximum friction. Okay, we'll do that later. Let us first understand what it is. So maximum limit is reached. Okay, that is the limiting friction. Okay, now the object starts sliding. Okay, starts sliding. Then what will happen to the friction? So the applied force is in this direction, friction in the opposite direction, but what is the magnitude of that friction? Okay, so here something strange happens. Okay, when the object starts moving, then the friction, right, limit of the friction, maximum, the frictional force drops a bit. Okay, it lowers its value, right, which means that is a constant value. The moment the object starts moving, the frictional force is reduced from the maximum value, right? So this reduced value is called by the name kinetic friction. Kinetic friction is little less than the maximum friction, that is the limiting friction, right? So when the object starts sliding, so it becomes little less than the limiting friction, right? You would have observed this practically, right? When you try to push an object, initially it is very difficult. Once the object starts moving, then it is relatively easier, right? Which means the opposing friction force is little less than the maximum friction. Do you understand? So the maximum value of the static friction, that is called the limiting friction. Now kinetic friction acts when the object starts sliding, starts moving, then kinetic friction acts. Kinetic friction is a constant value, that is a constant value, that is fixed. We have a formula to calculate the kinetic friction. We have a formula to calculate the maximum friction, the limiting friction, but there is no formula to calculate static friction. It is just against the applied force, right? That is equal in magnitude to the applied force, which is a variable force, right? So these are the three different types of friction. Let us understand these three types of frictions one by one. Okay, so we'll write formula to calculate the limiting friction, static friction, and also the kinetic friction, right? So let us do it one by one. Okay. Yes, the first one is the static friction. So let us do this in detail. So what is static friction? That is when the object is not moving. See, when you say not moving, there is no relative motion, right? No slipping between the surfaces. When both the surfaces are moving together, that is a different case. There is no relative slipping between the two surfaces. That's what we mean by the object is not moving. Okay, the object is not moving. Now, the friction that acts on the object is the static friction. When you apply a force, there is an opposing force. That force is called the static friction. This friction works as long as the object is not moving. Okay, so that is the first point. Static friction acts when the object is not moving. Okay, second point, it is a variable force, right? This static friction is a variable force, right? Because when you increase the force, the friction will also increase. There is a limit to it, but it will keep on increasing until that moment. Okay, so this is the variable force. What is this? What is the value of the static friction? That is same as the applied force. When a force is applied in this direction, the friction acting in the opposite direction is equal in magnitude, but opposite in direction, but the magnitude of the static friction is same as the applied force. That's all, right? So that is the point. So these are the things you have to know about static friction. So no formula or anything to calculate static friction, because if you apply some force, the friction is in the opposite direction, having the same magnitude. That's all. So that is static friction. Okay, so that is the first type of friction. Okay, yes. Next one is the limiting friction. Like we discussed, when the force is increased, the frictional force will also increase, right? The static friction will increase until it reaches its maximum value. That maximum value, right? The maximum value of the static friction is called the limiting friction, right? So that limiting friction is reached, then the object might start slipping, right? Yes, until that moment the object is at rest because the frictional force opposes the applied force, right? Equal in magnitude. That means the object is not moving. But when the maximum limit is reached, maybe the object will start sliding, right? So that maximum limit of the friction is called the limiting friction. Okay, so we have a formula to calculate this limiting friction. See, so the first point is that, so this limiting friction happens when the object is just about to start sliding, right? So just about to move. Okay, so because maximum limit is reached, so this limiting friction, okay, has this formula, the limiting friction, right? So denoted by this FL, right? So that is proportional to the normal force between the surfaces, right? So the normal force, this FL is proportional to the normal force, right? See, obviously, right, the weight, so if the object is heavier, then it is difficult to push this object, right, because of the normal force. So this frictional force is proportional to the normal force. Okay, yes, that means you introduce some proportionality constant. So FL, okay, is equal to a proportionality constant, so that is denoted by mu s. Okay, mu s multiplied by n. Okay, so mu s multiplied by n, this is the formula to calculate this limiting friction. But what is this mu s? This mu s is called the coefficient of static friction, right? So that depends on the surfaces, right? What is the material? So depends on the material, right? So that is fixed for a particular material, and the geometry of the material, many things are involved. So here, so that is given for a particular object, okay, a particular combination of object, so that mu s is fixed. Okay, so that should be known. Okay, so this limiting friction is mu s, coefficient of static friction multiplied by the normal force. Okay, yes. Now, so this is the limiting friction. You understand? So this is the constant value, right? For a particular combination of object, this is the constant value. So this is the maximum value to which this static friction can rise, right? So the maximum value of the static friction can be this limiting friction. Is that okay? So that is the limiting friction. So that has formula FL, the limiting friction, equals the coefficient of static friction multiplied by the normal reaction. Okay, yes. So this is about the limiting friction. Is that okay? The next one is the kinetic friction. So what is kinetic friction? See, when you keep on increasing the force, the friction will also increase, but it will reach the maximum limit. Now if you increase the force a little further, then this frictional force will drop a bit. Okay, it will reduce in value little bit. Okay, so now this force is more than the frictional force in the opposite direction. The object will start moving, right? When the object starts moving, then the frictional force acting on the object is called the kinetic friction. We can't use the static friction or the limiting friction. When the object is moving, then we have to use the friction, kinetic friction, right? Now just like the limiting friction, so kinetic friction also we have some points about it. So let us write one by one. So this kinetic friction denoted by Fk, that is also proportional to the normal force. Okay, just like the limiting friction, but this time the proportionality constant is little different. So Fk is equal to the proportionality constant is denoted by mu k, okay, multiplied by the normal force. There we wrote mu s, so here we write mu k. Okay, yes. Then this mu k is called the coefficient of kinetic friction, right? So what is kinetic friction? So that is when the object is moving, then this value mu k, right, you have to use instead of mu s. Okay, now first of all you have to check whether the object is moving or not. When the object is moving, we have to use this formula. If the object is not moving, we have to use the static friction. Okay, so now this mu k, called the coefficient of kinetic friction, is little less than the coefficient of static friction, right? Because we know that, so this friction value is little less than the maximum friction. So this mu k is little less than mu s, right? Usually, right, there are some exceptions, so there are very few exceptions, but usually this mu k, right, coefficient of kinetic friction is little less than the coefficient of static friction. But both coefficient of kinetic friction and coefficient of static friction, they are less than 1. Again, there are some exceptions, but in most of the cases these two values are less than 1, and also this mu k is less than mu s in most of the cases. Okay, yes. So these are the things you have to know about the kinetic friction. Now generally friction is a contact force, right? Unlike the gravitation force and other things, the friction is a contact force. When the surfaces are not in contact, there is no friction between the surfaces, right? It is a contact force, and also it does not depend on the area of contact. Okay, so this is one point you have to remember. So it does not depend on the area of contact. Okay, it only depends on the coefficient of friction between the two surfaces, does not depend on the area of contact. Okay, yes. So that's all. These are the points about the friction you have to know. See, generally, so what is the type of friction that acts on an object depends on whether the object is moving or not. See, let us draw the graph of the applied force and the frictional force. Initially, when you increase the force, the friction force will also increase. That is a static friction. That is a variable force, right? So if you increase the force, the friction force will also increase. That means it is a straight line, right? Equal. This force and the friction force are equal in magnitude. Okay, so that means the friction force will also increase, but it will reach the maximum limit. That maximum limit is called the limiting friction. So maximum limit is reached. Now you increase the force little further, then this friction force will reduce a bit. Okay, thereafter it will remain constant. So that constant frictional force is called kinetic friction. So this is the maximum limit of the friction, that is the limiting friction. Until that moment it is a variable force. Okay, friction is variable until that maximum value. After that it is reduced a bit and that remains constant thereafter, right? So even if you keep on increasing the force, the friction will not increase, it will remain constant. So that is called the kinetic friction. Okay, so constant for if the force exceeds certain limit. Okay, so this is the graph of the force, applied force versus the frictional force. Okay, yes. So that's all. So these are the points about the frictional force that you have to know. Okay, yes. Now which type of frictional force you have to use in a particular question, so that depends on whether the object is moving or not. So you can't use the kinetic friction straight away. You have to first check whether the object is moving or not. How will you check whether the object is moving or not? First of all, you have to find the applied force, right? There is some applied force and you have to find the limiting friction. You find the limiting friction. Now, if the applied force is more than the limiting friction, then the object moves, right? If the applied force in this direction is more than the opposite limiting friction, the object moves. When the object moves, then you should not use limiting friction. You have to use kinetic friction, because we have made sure that the object moves. When the object moves, you have to use the kinetic friction formula. That means mu k multiplied by n. Suppose the object does not move, which means the applied force is less than the maximum friction, then which friction we have to use? Not the limiting friction again, you have to use static friction, because when the object is not moving, this frictional force, this applied force is balanced by the other force, right? Opposite direction. So that force is just equal in magnitude, that is static friction. So the object is not moving, static friction we have to use. When the object is moving, you have to use kinetic friction. But whether the object is moving or not, how will you know? Using limiting friction, right? Limiting friction you find if it exceeds the applied force, the object does not move. If the limiting friction is less than the applied force, the object moves. So use the kinetic friction. Alright, so these are the points you have to know before we start solving questions. Alright, so let us use all these concepts and solve some questions. Okay. Here we have a block kept on a rough surface and a 30 Newton force is acting on this block in the horizontal direction. We have to find the acceleration of the block. Now we have a force in this direction against which we have the frictional force in the opposite direction, right? So first thing we have to do is check whether this object moves or not. This object will move only when the applied force, right, 30 Newton force, that exceeds the limiting friction. What is limiting friction? That is the maximum amount of friction, right? If this force exceeds the limiting friction, only then will the object move, right? Let us calculate the limiting friction first. Alright, so what is the formula for the limiting friction? So the limiting friction denoted by FL. So that has formula mu s, right? The coefficient of static friction multiplied by the normal reaction. Alright, yes. So mu s is given in the question, so that is 0.7. multiplied by, but the normal force is same as mg, right? If you consider the vertical forces, so normal force in the upward direction, mg in the downward direction, they balance each other, right? So that means n is same as mg, so we can substitute these values here. So 0.7 and the mass of the object 5 kilogram and g is 10, so that is 35 Newton. Okay, so that is the maximum amount of friction, right? That is the limiting friction. Okay, now this force is more than the applied force, right? That means, so this object will not move, right? So even if the force is 35, so still this force will prevent the object from moving, right? The friction force is against the applied force. So this force 35 Newton, that is more than the force 30 Newton. So this force is more than, right, the frictional force. Only when our applied force exceeds this limiting friction will the object move. Okay, so that means here in this case the block does not move. Okay, so the block does not move, so that means what is the acceleration of the block? So that is 0. So that's all. So 0 is the acceleration of the block. Alright, so that's it. Yes. Now what is the frictional force then? What is the frictional force working on the object? So that is not 35 Newton. No, that is not the frictional force. This is the maximum amount of friction. So that is not the exact amount of frictional force working in this case, right? See, the object is in equilibrium. That means these two forces balance each other. So that means, so the friction here, right? The friction here is, the object is not moving. When the object is not moving, the frictional force is the static friction, not the limiting friction. The limiting friction is the maximum amount of friction. So when the object is not moving, the frictional force on the object is the static friction. So static friction does not have any formula. Alright, so the friction here is the static friction. So then we have to consider the other forces. So this object is in equilibrium. So what are the forces acting on the object? 30 Newton in this direction. Okay, so 30 Newton minus the frictional force. F, yes, Fx is the static friction. So 30 Newton in this direction, static friction in the opposite direction. So that must be equal to 0 because the object is in equilibrium. Alright, so that means the frictional force acting on the object is simply 30. That's all. So 30 Newton is the frictional force. So that is same in magnitude, right, to the given applied force, right, opposite direction. That is why the object is in equilibrium. So static friction, so that is a variable force, right, that depends on the other forces, right? So 30 Newton is the applied force and same 30 Newton is the frictional force, because the frictional force here is the static friction, not the limiting friction or kinetic friction. Okay, so we use just the equilibrium condition to get the static friction, right? That is 30 Newton. Alright, so that's all. So the acceleration of the object is 0 and the frictional force on the object is 30 Newton. Okay. Here also we have to find the accelerations of the blocks. First of all, we have to check whether the blocks move or not. For that, the applied force should exceed the frictional force, right, the limiting friction. So the block of mass 3 kilograms, right, let's consider that. What are the forces acting on this block in the horizontal direction? Tension due to the shrink, right, tension force in this direction. Is the tension force more than the limiting friction? So that's what we have to check, right? Let us calculate the limiting friction. So if it exceeds the tension force, the object will not move. Alright, so let us calculate. See, first of all, the limiting friction, okay, FL. Alright, so limiting friction, so that equals, so mu s multiplied by n. Okay, so that is for the 3 kilogram block. So there is no friction acting on the other block 2 kilogram, right? So only 3 kilogram blocks has some frictional force, right, because it is in contact with the surface. So now let us calculate this mu s multiplied by n. So mu s is given, so that is 0.2 multiplied by the normal force is mg only, right? So mg in the downward direction, normal force, they balance each other. So it is 0.2 multiplied by 3 kilogram multiplied by 10. So that is 6 Newton. So that is the maximum amount of friction. Does it exceed the tension force? For that we have to calculate the tension force, right? Yes. Now, but we don't know whether the blocks move or not. So how to calculate the tension force? See, the tension is maximum when the blocks are in equilibrium, right? That is the maximum amount of tension. So let us calculate it. Let us consider that the blocks are in equilibrium, which means they are not moving. So now take the 2 kilogram block. What are the forces acting on the 2 kg block? So the gravitation force is in the downward direction, 2g minus the tension in the upward direction, so equate it to 0. Let me calculate the maximum amount of tension, right, equating it to 0. Suppose the blocks are not moving. So what is the tension here? So this gives you the tension here equals, so 2 multiplied by 10, so that is 20 Newton. So 20 is the tension acting on this block in the horizontal direction, but what is the limiting friction? So 6 Newton only. So this 20 Newton force is more than the limiting friction. That means this block will move because the applied force is more than the limiting friction. So that means the object moves, right? The acceleration is not 0. Okay, let us calculate now. Now again, that means it's not in equilibrium. So they both the blocks move with the same acceleration because they are connected directly, right? So they move with the same acceleration. So let us calculate that 3 kg block. What are the forces acting on the 3 kg block? So that is the tension force in this direction, tension force, minus the minus the frictional force. But what is the frictional force? That is not this one, right? That is not this force, right? This is the limiting friction. So that is not the exact amount of friction acting on that block. Alright, no. This is only the maximum amount of friction. But we have made sure that the object moves. When the object moves, what type of friction acts on the object? So that is the kinetic friction, not the limiting friction or static friction. Kinetic friction. The object moves. That means kinetic friction, right? There is a relative motion between the block and the surface. That means we have to use the kinetic friction formula. What is the kinetic friction formula? So that is Fk multiplied by m. Alright, so that equals mass times the acceleration. 3 multiplied by the acceleration of the block. So let us take it as A. Okay, so kinetic friction we have to use. Okay, now this is for 3 kg block. Okay, let me simplify this. So the tension, so don't use the tension value, this one. So this is the maximum possible tension considering the object to be in equilibrium, but that need not be the exact amount of tension here. So T as it is minus Fk, so that is known, so that is 0.1 multiplied by, again the normal force is same as the gravitational force, so that is 3 kg, which means 3g, that equals 3 times A. So this gives you T minus this is 3, T minus 3 equal to 3 times the acceleration. Okay, this is for the 3 kg block. Similarly, so we can calculate for the other block, 2 kg block. So for the 2 kg block, what are the forces acting on that block? So again, the gravitation force in the downward direction, so 2g minus tension force in the upward direction, that equals 2 times the acceleration. So same acceleration. Okay, both the blocks move the same acceleration. 2g minus t equal to 2a. Okay, yes. Now what we do? So let us simplify this. Okay, so we don't need the tension, so we can just add these two. So if you add these two equations, we get t gets cancelled. It is 2g minus 3 is equal to 5a. So that's all. That gives you our required acceleration of the blocks. So 2g is 20 minus 3, 17 divided by 5. So this is the acceleration, 17 divided by 5. This is the acceleration of both the blocks, right? Both the blocks move with the same acceleration. So that has magnitude 17 by 5. Okay, so that is the answer. Now what type of frictional force acting on this object? So in the 3 kilogram block, so the frictional force acting on this block is this kinetic friction, right? Fk multiplied by n. So that is same as this 3 Newton. That's all. So that is the frictional force acting on the block, and this block moves with acceleration 17 by 5. So that is the answer. Here again we have a block, a force is acting on this block in the horizontal direction. We have to check first of all whether this block moves or not. But for that we have to find limiting friction. But what is limiting friction formula? So that is mu s, that is the coefficient of static friction multiplied by the normal reaction. But that is not given in the question, right? Mu s is not even given in the question. Only mu k is given. So mu k can be used only when you know that the object moves. Okay, but we don't even know whether the object moves or not. Right, so we have to find the limiting friction and to make sure that the object moves. Okay, this force should exceed the limiting friction, but we don't even have the value of mu s. Okay, assume that the object moves. Okay, so because we don't have any other option now, assume that the object moves. Then the kinetic friction. Okay, suppose the object moves. So then what are the forces acting on the 6 kg block? So that is the 6 kg block. What are the forces acting on the block? 20 Newton in this direction. So 20 minus, in the opposite direction we have the kinetic friction. Okay, So because we have assumed that the object moves, so that means mu k multiplied by n. So that equals mass of the object is 6 multiplied by the acceleration. Okay, so let's simplify this. This is 20 minus, so this is 0.5. N is the normal reaction, that is same as mg, which is 6g. So that equals 6a. So what is this value? 20 minus 30 is equal to 6a. So we are getting the value of a. So that is minus, okay, minus 5 divided by 3. So this is the acceleration of the block. But the acceleration is negative. What does it mean? The object moves in the opposite direction, okay, in this direction, right, negative direction. But is that even possible? See, 20 Newton force, right, is acting in this direction. No matter how big the value of the friction is, right, still the object will never move in the backward direction, right? So as long as this force, right, does not exceed the limiting friction, the object will be at rest. If the force exceeds the limiting friction, the object will start moving in this direction. Never will the object move in the opposite direction. It is not even possible. So negative, that means our assumption is wrong, right? What have we assumed here? We assume that the object is moving. That is why we use the kinetic friction. So negative minus 5 by 3 opposite direction. So not possible. So this is not possible. Okay. So the object will never move in the opposite direction, right? Friction cannot lead the object, right? So it can only prevent the object from moving, right? So there is no relative motion because of the friction, right? Otherwise it will not move the object in the opposite direction. That is not possible. So minus 5 by 3 not possible. That means the object does not move. We can conclude that the acceleration is 0. The object does not move. The acceleration is 0. Okay. But what if you get the answer acceleration as a positive value? Can you conclude that the object moves then? No, we are not sure. So if the object moves, okay, suppose you are getting the acceleration as a positive value, still we can't conclude that the object moves, because first of all we have to make sure that the object moves or not. We have not even made sure. We simply use the formula. Even if you get a positive value, we can't conclude, okay. But when you get negative value, we can conclude that it is wrong, right? This is definitely wrong, right? So that means, so the object does not move. But when you get a positive value, then we are not sure. The object may not move, because there is a difference between the coefficient of kinetic friction and static friction. So that difference will make, okay, so we have to make sure first of all whether the object moves or not. Only then you are supposed to use the kinetic friction. But we have directly used it. So if you get positive value, we are not sure. But you get negative value, definitely it is wrong. So the object does not move, so the acceleration is 0. Okay. Okay, same question, but a variable force is given. We have to find the acceleration of the block in 10 seconds and 30 seconds. As usual, we have to find the limiting friction and check whether it is more or less than the applied force. Alright, so let us find the limiting friction. So that has the formula. So FL equals, okay, so mu s multiplied by the normal reaction. So mu s is given in the question, so 0.5, the normal reaction. So that is mg, right? So mg is 2g. Okay, so this equals, so this is 20 multiplied by 0.5, so that is 10. So 10, that is the limiting friction. Is it more or less than the force? The force is not fixed, right? So it is a variable force. So we have to consider these two cases. So the first case, so we have 10 seconds. In 10 seconds. In 10 seconds, what is the force? So the force here equals 2t divided by 3, but in 10 seconds, so that is 2 multiplied by 10 divided by 3. Okay, so that is 20 divided by 3. So that is the force. Is it more or less than the limiting friction? So this is 10, this is 20 divided by 3, so that is less than the limiting friction. Okay, so this force, the applied force, is less than the limiting friction. So then we know that the object does not move. That means the acceleration is 0, which means the answer to the first question. So that is in 10 seconds the acceleration is 0. Okay, yes. Now second one, in 30 seconds. In 30 seconds, so what is the force here? Same thing, 2t divided by 3. So it is 2 multiplied by 30 divided by 3. So that is 20. 20 is the force in 30 seconds, but that is more than this 10, right? So when the force is more than the limiting friction, the object moves. When the object moves, we have to consider the kinetic friction. So that means, what are the forces acting on the object now? So the applied force, so F minus kinetic friction, right? So that means mu k multiplied by the normal reaction. This is the total force acting on the object. So that must be equal to mass times the acceleration of the object. So that's all. So the force here is this one 20 minus the kinetic friction. So for that we have to use the other formula, 0.4 multiplied by mg. So m is 2 kilograms, so 2g. So that equals mass times the acceleration, 2 multiplied by acceleration. So that's all. That will give you the acceleration of the block. So what is it? So 8, so 20 minus 8, which is 12 divided by 2, 6. So that's all. So 6 meter per second square. So that is the acceleration of the block. Alright. So same idea, right? But just two cases we have used. Alright. So here in the first case, the object does not move because the limiting friction is more than the force. So here it is less than that. Then we have to use, instead of the static friction, okay, or instead of the limiting friction, you have to use the kinetic friction because the object moves here. Okay, so that's all. So that gives you the acceleration of the block. So that is 6. Okay, the acceleration of the block of mass capital M given in the figure is. Here also we have a force acting on the block, but this time the force is not acting in the horizontal direction. It is inclined at some angle with the horizontal. For what angle will the force be minimum, right? We don't know. For what angle the force will be minimum, right? We have to find the minimum value of that force. Okay, yes. What if the angle is 0, right? So that means it is horizontal. If it is horizontal, that is when we have the maximum amount of force. But when the force is maximum, this frictional force against it is also maximum, because normal reaction will be less in that case. So force is maximum, friction will also be maximum, right? But if you increase the angle, right, so the friction will be less, because normal reaction in that case will be less than the normal reaction when the force is horizontal. When the friction is less, the force will also be less, right? So because if it is inclined at some angle, you will only take the component of the force, not the complete force, component of the force, right? F cos theta. So force will also be less when the friction is less. So we have to find a balance. Alright, so when the force is maximum, friction is also maximum. When the force is minimum, friction will also be minimum. So we have to find a balance at some point. Alright, we need only the minimum amount of force. What value of the angle theta we have, we need only the minimum force. Okay, that's what we need to find. For initially we don't know the angle. Let us take the angle to be theta. Okay, let's take the angle to be theta. Now let us consider the vertical direction. So what are the forces acting in the vertical direction? Yeah, vertical direction. Gravitational force in the downward direction, so mg, and then normal reaction in the upward direction, minus m, and also the component of the force in the vertical direction, right? Because the force is not horizontal, it has a vertical component. Theta with the horizontal, 90 minus theta with the vertical, f sin theta, right? That in the vertically upward direction. So minus f sin theta. So this is the total force, so that equal to 0, right? So the object is okay, no vertical motion, right? So that means this total is 0. Okay, yes, that will give you the normal reaction. So what is normal then? Mg, okay, mg minus f sin theta. So this is the normal force acting on the block. Okay, we'll use it later. Okay, now let us consider the horizontal direction. Let's consider the horizontal direction. What are the forces acting on the block in the horizontal direction? Now we have the component of the force in the horizontal direction, right? Component of the force. Okay. So that component should exceed the limiting friction. Only then the object will move, right? So that means F sin F cos theta, that is the horizontal component of the force, that should exceed. Okay. So that should be more than the limiting friction, right? So this should be more than the limiting friction. Only then the object will move. Okay, so that means, so this should be greater than FL. What is FL? Mu s multiplied by the normal reaction. That normal reaction is what we have found here. Okay, that can be substituted. So mu s multiplied by normal, which is mg minus f sin theta. Okay, yes. Now, okay, so now let us simplify this. Mu s is what we need to find. Yes, let us simplify this. So f cos theta is greater than, so this value. So that means our force F is greater than, if you take common, so you bring this F sin theta this side, F mu s sin theta, and then divide. So that should be greater than mu s mg divided by F, if you take common, cos theta plus mu s F sin theta, mu s sin theta. Okay, cos theta plus what do you get, mu s sin theta. Yes, mu s sin theta. Okay, now this force, our required force F must be greater than, so this value. Okay, but it is dependent on theta. So we want to get an answer independent of theta. For what value of theta, this value will be minimum. For that we have to use a little bit of math, right? Some basic trigonometry. So do you know the maximum value of an expression like this? A sin theta plus B cos theta. What is the maximum value of this A sin theta plus B cos theta? So this is like a formula from trigonometry, A squared plus B squared. So this is one formula that we are going to use. So A sin theta plus B cos theta is always less than equal to, so this is the maximum value, less than or equal to A square plus B square. Okay, so isn't it like this? Something like 1 cos theta plus mu s sin theta, something like A cos theta plus B sin theta. That is less than equal to square root of A square, which means 1 square plus B square, which is mu s square. So this value is greater than or equal to mu s mg divided by the maximum value of this, right? So that is square root of, okay, so A square, which is 1 square plus B square, so that is mu s square. So that's all. So this is the maximum value of, the minimum value. F should be greater than that. That means the minimum value is this, right? So for this angle, so for what value of theta? Theta is not required. For some value of theta, so this maximum is attained. So this is the minimum force required to move this object for some angle, right? So because the angle is not fixed, okay, some angle, we don't know for what angle. So this is anyway the minimum value of the force F, right? Because F is always greater than that value. So that is the minimum force required to move this object, right? So, but this is not the horizontal force, right? So this force is the minimum only when this makes some angle theta, okay, some angle theta. So if you solve this equation, you will get that angle theta. We don't need that, but this is the minimum possible force that can move this object, right? So that is the answer, mu s mg divided by root 1 plus mu s square. Okay. Just like last question, here also we have a force acting on a block in a direction making angle some theta with the horizontal, right? But we don't know whether it is a pushing force or pulling force, right? So there are two possibilities like this, right? We don't know which one of these is given in the question. So we have to consider these two cases, alright? So suppose it is a pushing force, right? Does it make any difference, right? It makes a difference because of the friction, right? If there is no friction, right, whether it is a pushing force or pulling force, we have to take its component in the horizontal direction. So that means F cos theta, there also F cos theta, that is the only force acting on the block in the horizontal direction. It doesn't matter whether it is a pushing force or pulling force. So in both the cases, we will get the same acceleration. But that is not the case when there is a friction between the surfaces, right? Because so the normal reactions are different in these two cases, right? So let us consider these two cases separately. Okay, so the first case. So this is the first case, case 1, okay. So that means it is a, okay, pushing. Like this, okay, the first case. Now, what is the normal reaction in this case? Let us find the vertical. So what are the forces acting in the vertical direction? So vertical direction. So mg in the downward direction, so mg. And then the component of this force in the vertical direction, that is F sin theta in the downward direction, F sin theta. So that means F sin theta in the downward direction. And so we also have the normal force in the upward direction. So minus n equal to 0, or I'll take equal to n. Okay, so minus n equal to 0. So normal force is this mg plus F sin theta in the first case. Okay, done. Normal is known. Now we take the horizontal component. What are the forces acting in the horizontal direction? So the horizontal forces are again the component of the force in the horizontal direction. That is F cos theta, right? F cos theta. So F cos theta minus the frictional force, right? The frictional force is what? Suppose the object is moving, so that means mu k multiplied by n, right? So mu k multiplied by n. So that equals the mass times the acceleration. Okay, but what is n? So that should be written from this. Okay, so that's all. So this will give you our required answer. Let me write it directly. So what is the acceleration from this? So acceleration here equals F cos theta minus mu k multiplied by this n, but that n is already found here, that can be substituted, mg plus f sine theta. Okay, so this thing divided by this m. That's also, this is the acceleration in the first case, right? This is a pushing force, right? Like this. Now similarly, so we have to consider the other case, right? The case 1, case 2. So it is pulling force. Okay, so in that case, what are the forces acting in the vertical direction? So what are the forces acting in the vertical direction? So again, mg in the downward direction, so mg, yeah, okay, mg in the downward direction, but the component of the force F in the vertical direction, that is in the upward direction, right? Minus, because mg in the downward direction, so that is negative, so minus F sine theta. Normal reaction also in the vertically upward direction, so this equals n, right? This is the normal reaction in the second case. Okay, so that is done. Now let's take the horizontal components. So what are the forces acting in the horizontal direction? So that is same thing, F cos theta in the horizontal direction, and frictional force in the opposite direction, so minus mu k multiplied by n, so that equals the mass times the acceleration. So that gives you the acceleration, so that equals, what is the acceleration? F cos theta, okay, minus mu k n, but mu k n is known, so what is the value of n? Mg minus F sine theta, mg minus F sine theta. Okay, so this whole thing divided by m. That's all. This is the acceleration in the second case, but these two are different. Okay, so here the acceleration, so let us call it say a1, right? Acceleration in the first case, so that is a1. So acceleration in the second case, so that is taken as a2. So which is bigger, a1 or a2? See here, you see here also F cos theta, F cos theta, same thing, but here we are subtracting this value, here we are subtracting this value, but here we are subtracting a bigger value, right? Because mg plus F sine theta, here mg minus F sine theta, we are subtracting bigger value, that means this is smaller, right? So here you see a1 is actually less than a2, so a1 is less than a2, that means you tell me which one of these is easier to move this object, which one is easier? See, a1 in the first case the acceleration is less, okay, the first case acceleration is less, so that means it is harder to move the object in the first case, right? It is harder, which means pushing. Okay, so pushing is harder compared to pulling, right? So why? Because it makes some angle that contributes to the normal reaction also, right? That force contributes to it, lifts the object upward, right? In the second case it lifts the object upward, so that is why. So this second one, right? So pulling is easier compared to pushing, not when there is no friction, right? There is a friction, so in this case the pulling, right, is easier compared to pushing. So but anyway, the answer to the question, this is one possible expression for the acceleration. This is one possible expression for the acceleration. Not only that, there is one more answer possible. The acceleration can also be zero, right? So we don't know whether the object moves or not, right? So because mu s is not even known, right? This is when the object moves. We assume that the object moves. So we have taken the kinetic friction, right? Because we assume that the object moves. Kinetic friction. But what if the object does not move only? We have not even verified that. So also there is another possibility, acceleration can be zero, maybe possible, right? That is also one of the possible answers, right? If the object moves, the acceleration may be this or this, depending upon which is the direction of the force. But if the object does not move, that is also one possibility, acceleration can be zero, so that means the answer can be